Section 1.5 Order of Operations. In this video we will learn the proper order in which to evaluate an expression with how grouping symbols remove the ambiguity of an expression, rules guiding order of operations, fraction expressions, and the distributive property. Section 1.5 Order of Operations. The order in which we evaluate expressions can be ambiguous. Take, for example, the expression 4 plus 3 times 2. If we do the addition first, then we have 4 plus 3 equals 7, and 7 times 2 equals 14. On the other hand, if we do the multiplication first, then we have 3 times 2 equals 6, and 4 plus 6 equals 10. So, what are we to do? Of course, grouping symbols can remove the ambiguity. Grouping symbols, parentheses, brackets, or curly braces, can be used to group parts of an expression. Each of the following are equivalent. In each case, the rule is evaluate the expression inside the grouping symbols first. If grouping symbols are nested, evaluate the expression in the innermost pair of grouping symbols first. Thus, for example, note how the expression contained in the parentheses was evaluated first. Another way to avoid ambiguities in evaluating expressions is to establish an order in which operations should be performed. The following guidelines show always to be strictly enforced when evaluating an expression. Rules guiding order of operations. When evaluating expressions, proceed in the following order. 1. Evaluate expressions contained in grouping symbols first. If grouping symbols are nested, evaluate the expression in the innermost pair of grouping symbols first. Second, evaluate all exponents that appear in the expression. Third, perform all multiplication divisions in the order that they appear in the expression, moving left to right. And fourth, perform all additions and subtractions in the order that they appear in the expression, moving left to right. So 1 is parentheses, 2 exponents, 3 multiplication and division from left to right, 4 addition and subtraction from left to right. Example 1. Evaluate 4 plus 3 times 2. Solution. Because of the established rules guiding order of operations, this expression is no longer ambiguous. There are no grouping symbols or exponents, so we immediately go to Rule 3. Evaluate all multiplications and divisions in the order that they appear, moving left to right. After that, we invoke Rule 4, performing all additions and subtractions in the order that they appear, moving left to right. So, multiplying first, we get 3 times 2 is 6, then by addition, 4 plus 6 equals 10. Thus, the correct answer to the expression is 10. Example 2. Evaluate 18 minus 2 plus 3. Solution. Follow the rules guiding order of operations. Addition has no precedence over subtraction, nor does subtraction have precedence over addition. We are to perform additions and subtractions as they occur, moving left to right. 18 minus 2 plus 3 equals 16, then 16 plus 3 equals 19. Example 3. Evaluate 54 divided by 9 times 2. Solution. Follow the rules guiding order of operations. Division has no precedence over multiplication, nor does multiplication have precedence over division. We are to perform divisions and multiplications as they occur, moving left to right. So, we have 54 divided by 9 equals 6, then 6 times 2 is 12. Example 4. Evaluate 2 times 3 squared minus 12. Solution. Follow the rules guiding order of operations. Exponents first, then multiplication, then subtraction. So evaluating the exponent first, 3 squared, or 3 to the second power, is 9. Then multiplication, 2 times 9 is 18. Then 18 minus 12 is 6. Example 5. Evaluate the expression. Follow the rules guiding order of operations. Evaluate the expression inside the parentheses first, then exponents, then multiplication, then addition. So, doing the multiplication first within parentheses, we get 2 times 5 is 10. Then, applying addition within parentheses, 3 plus 10 is 13. Then, 13 squared, or 13 times 13, is 169. Then, by operation 3, 2 times 169 is 338. Then all that remains is to add 12 to 338 to get 350. So the simplified answer is 350. Example 6. Evaluate the expression. Solution. When grouping symbols are nested, evaluate the expression between the pair of innermost grouping symbols first. Innermost grouping first is 2 plus 2 equals 4. Multiply next. 2 times 4 equals 8. Then add inside the braces to get 2 plus 8 equals 10. Then multiply to get 2 times 10 equals 20. Fraction bars. Consider the expression. Because a fraction bar means division, the above expression is equivalent to the top part divided by the bottom part. The position of the grouping symbols signals how we should proceed. We should simplify the numerator, then the denominator, then divide. Fractional expressions. If a fractional expression is present, evaluate the numerator and denominator first, then divide. So we want to simplify in the numerator and simplify in the denominator before we do the division. Example 7. Evaluate the expression. Solution. Simplify the numerator and denominator first, then divide. Parentheses in denominator first. 2 plus 3 equals 5. Exponents are next. 6 squared equals 36, 8 squared equals 64, and 5 squared equals 25. Add in the numerator. 36 plus 64 equals 100. Then divide 100 by 25 to get 4. The distributive property. Consider the expression 2 times 3 plus 4. If we follow the rules guiding order of operations, we would evaluate the expression inside the parentheses first. 3 plus 4 is 7, and 2 times 7 is 14. However, we could also choose to distribute the 2, first multiplying 2 times each addend in the parentheses. 2 times 3 plus 2 times 4. Then 2 times 3 is 6, and 2 times 4 is 8, then 6 plus 8 is 14. The fact that we get the same answer in the second approach is an illustration of an important property of whole numbers, distributive property. Let a, b, and c be any whole numbers. Then a times the sum of b and c is equal to a times b plus a times c. We say that multiplication is distributive with respect to addition. If you are not computing the product of a number and a sum of numbers, the distributive property does not apply. Caution! Wrong answer ahead. If you are calculating the product of a number and the product of two numbers, the distributive property must not be used. For example, here is a common misapplication of the distributive property. 2 times 3 times 4 is not equal to 2 times 3 times 2 times 4, which leads to 6 times 8, which leads to 48. This result is quite distant from the correct answer, which is found by computing the product within the parentheses first. 3 times 4 is 12, and 2 times 12 is 24. In order to apply the distributive property, you must be multiplying times a sum. Example 8. Use the distributive property to calculate 4 times 5 plus 11. Solution. This is the product of a number and a sum, so the distributive property may be applied. Distribute the 4 times each addend in the sum to get the product of 4 and 5 plus the product of 4 and 11. Then multiply. 4 times 5 is 20, and 4 times 11 equals 44. Then add 20 plus 44 equals 64. Readers should check that the same answer is found by computing the sum within the parentheses first. The distributive property is the underpinning of the multiplication algorithm learned in our childhood years. Example 9. Multiply 6 times 43. Solution. We'll express 43 as sum, then use the distributive property. 6 times 43 equals 6 times 40 plus 3. Distribute the 6 to get the product of 6 and 40 plus the product of 6 and 3. And 6 times 40 equals 240, and 6 times 3 equals 18, then 240 plus 18 equals 258. Readers should be able to see this application of the distributive property in the more familiar algorithmic form. 6 times 3 is 18, 6 times 4 is 24, then 18 plus 240 with 0 holding the place value is 258. Or in the even more condensed form with carrying, 6 times 3 is 18, and 6 times 4 is 24 plus 1 is 25. so the result is 258. Multiplication is also distributive with respect to subtraction. The distributive property, subtraction. Let A, B, and C be any whole numbers. Then A times the difference of B and C equals the product of A and B minus the product of A and C. We say the multiplication is distributive with respect to subtraction. Example 10. Use the distributive property to simplify 3 times 12 minus 8. Solution. This is the product of a number and a difference, so the distributive property may be applied. When we distribute the 3, we get the product of 3 and 12 minus the product of 3 and 8. 3 and 12 equals 36, and 3 times 8 equals 24. Then 36 minus 24 equals 12. Alternate solution. Note what happens if we use the usual order of operations to evaluate the expression. First, evaluate within parentheses. 12 minus 8 is 4, then multiply 3 times 4 to get 12. The same answer.